It's your favorite NPC, and over the next 2 hours, I'll teach you everything you need to know about HTML Canvas. By the end, you'll be able to create particles like these ones. And I'll not only explain the theory, we're also going to build all of those cool particle effects together. By the end of this course, you'll understand HTML Canvas and you'll at least be able to create those cool effects. So let's get started, guys. HTML Canvas is an HTML element that lets you draw and render graphics directly in the browser using JavaScript. It's mainly used for visuals like animations, games, and particle effects. If you want to create modern websites that include particle effects, for example, you could use HTML Canvas for that. To get started using the canvas, we of course need to use HTML and JavaScript. And in order to write HTML and JavaScript, we could use a code editor. And I'm going to use VS Code in this course, so feel free to use VS Code as well, but you can also use another editor. To get started, we should first create a new project. So let's go here, open folder, and now we should create a new folder for our project. I'm going to create this folder on my desktop, so I'll go to desktop. I'm going to right click right here, new folder, and this will have the name canvas-course, for example. I select this folder, and this will be the folder for my project. In order to create a canvas, we should now create an index.html file, like so. And let's also start by creating a basic template. Now that we've got this template, we can open our HTML page using the live server. So right click, open with live server, and this should open your page right here. And in case you don't have the live server yet, you can just go over to extensions right here, search for live server. This is the live server, so click the live server and you can just press install right here. And the benefit of using the live server is that we can now enter something on our HTML page, like hello for example, and this will automatically update our web page, as you can see. But now let's get started by using our canvas. And to use an HTML canvas, we can just use the canvas element like so. And this will create our canvas. But at the moment we're not able to see the canvas. So let's use a style shield in order to do so. So let's create a style.css file, and let's start by linking the style sheet to our HTML page. So link :CSS to link our style shield, and now let's target our canvas. Let's use an ID, for example. ID could be canvas, and now let's target #canvas inside of CSS, and let's use a border of 1 pixel solid black. And as you can see, this right here is our canvas. Let me also reset all of the HTML styles, so all of the base styles, by using the universal selector, like so, margin 0, padding 0, and box sizing of border box, like so. So this will just reset the styles that our browser applies by default. But now this here is not that important. Let's start by using JavaScript. So let's create an index.js file, and let's link this index.js file within our index.html file. So right here, let's use a script :source tag to link our index.js file. And right here, we also need to use the defer attribute that tells our browser to parse this JavaScript file after all of the HTML code has been parsed. And now let's get a reference to our canvas within our index.js file. So const canvas is going to be equal to document get element by ID, and the ID name was canvas, because of course the ID I used right here is canvas. So now we only have the reference though. Let's also define a width and a height for our canvas. And just remember that it's important that you use JavaScript to define the width and the height of the canvas instead of CSS. So now we can just say canvas.width is going to be equal to our window.inner width, like so. And you can see now the canvas spans the entire page. So the entire width essentially. Now for canvas.height, we could say we want to have window.inner height, for example. And now I can see the canvas also spans the entire height of our window. But this right here is not necessary. You could of course also define a certain width of maybe 200 and a certain height of maybe 500. So that is up to you. But oftentimes you just use window.inner width and window.inner height to span the entire width and height. Now let me also remove the border because that one doesn't look too good at this point. And let me just use a background for our canvas of maybe black. Doesn't matter too much for now. You can see this here is also looking a little bit weird. We are having those weird scroll bars, but let's get rid of them by defining for our body an overflow of hidden, for example, like this. And you can see now this looks pretty nice. So now this here is essentially our canvas. So this here is our canvas that spans the entire page. And now we can draw something on our canvas. So we can draw rectangles, circles, and so on. But first of all, in order to draw something, we need to create an object, a context object. So I can say that a variable const, and the name is up to you. I like to call it ctx for context. This is going to be equal to canvas.getContext, like so. And now we could, for example, create a 2D context. So 2D right here. And all this line here is saying is that we want to create a context object, and this context object can be used to use a lot of different methods to draw stuff on the screen. So essentially, canvas.getContext just returns a lot of 2D specific methods to draw onto the canvas. And let me start by showing you the first one. The first one could be used to create a rectangle, for example. So we'll access ctx, which provides a lot of different methods to draw onto our canvas. And now we could, for example, use fill rect for fill rectangle. And you can see we need to insert a couple of different values. An x value, a y value, a width, and a height. So let me first of all enter all of those numbers and then I'll explain them to you. So maybe we can say 100, 200, w could be 50, and height could be 50, like so. So I'm going to save this. And at the moment we are not seeing anything because we're drawing black on black. So if I'm going to remove for hashtag canvas the background, you can see that we now have this rectangle right here, but the color is black. So we could also just change the color of our rectangle by saying ctx.fill style being equal to, and now we can define a color right here. This could be white, for example. And you can see the rectangle is now white. But this here could also be an RGB value, so RGB, or an RGBA value. So RGB 255, 255, 255, which is of course equal to white, would be valid as well. And you could also use RGBA of 255, 255, 255, 0.4, for example. And this is valid as well. And you could also use a hash code. So maybe hashtag FFF, like so, which would also be white. So I can just use normal color codes essentially. Now let me also explain how this here works. So the first value right here is our x value. Our x value defines the distance on our x-axis. So it essentially defines the space from here, so from the left, to our rectangle. The second value is our y value. That one defines the distance from the top of our page to our rectangle. So essentially that one defines this one right here. So this is x and this is y. The third value defines the width of our rectangle. So essentially it defines the width of the square. And the last value defines the height. So essentially that one right here. So those are all of the values. Now let me also create a second rectangle. So let me say ctx.fill rect. And let's say this here is a little more to the right. So let's say 200, 200, 50, 50, for example. And you can see now we have a second rectangle right here. And you can see ctx.fillStyle also applies to the second rectangle. If we wanted to change the color of our second rectangle though, then we could change ctx.fillStyle right before creating it. So this ctx.fillStyle applies to all of the upcoming elements essentially, unless we state otherwise. So if we right here say ctx.fillStyle is going to be equal to yellow, for example, then up to this point, all of the elements will have the fill style white, and from this point on, all of the elements will have the fill style yellow. So you see this one is now yellow, and all of the other ones would also be yellow. So 300, for example, would be yellow, 400 as well. So this is how this works. But now we could also define a shadow. So we could say ctx.shadow blur, for example. And this is going to be equal to 20, for example. So 20 pixels. And you can see that we are not seeing anything. And the reason for this is that our shadow color is black at the moment. So let me also change the shadow color. So ctx.shadow color is equal to yellow, for example, as well. And now you can see that we have our shadow right here. And now if I change the shadow blur, you can see that the strength of our shadow essentially changes. So 40 and so on. So all of those properties start to apply from the line where you essentially defined it. So ctx.shadowblur will affect all of the upcoming elements right here. ctx.shadowColor will affect all of the elements right here, and so on. So I think you get the idea. And that is how you create a rectangle using Canvas. But now there exist a lot more elements, so let me show you a couple of them. And something that you want to use pretty often is a line, for example. So let's create a line. In order to create a line, we first of all want to begin a path. So we use ctx.beginPath, like so. So this says begin a new path. Now to define the starting point of a line, we use ctx.moveTo, for example. And right here we have to enter an x value and a y value. And that x and y value defines the starting point of our line. So if we enter 100 for x, this means move 100 pixels on the x-axis, and the same of course for y. So 100 on y would mean move 100 pixels on the y-axis. So let's use 100 and 100 for example. Now we could also define an ending point. So ctx dot, to define the ending point, let's use line 2. And let's for example say 200, 100. So we'll only move on the x-axis. So essentially we'll probably start around here, 100, 100, and we'll move to 200, 100. So over here. But now we are not able to see our line. So let me use ctx.stroke. So this will now draw our line. But again, we are not able to see the line because our background is black. So this here is the line. But of course, we can also change the color of our line by just using right here, for example, ctx dot, and previously for a rectangle, we used fill style. But for a line, we have to use stroke style, like so. And our stroke style is going to be white, for example. And of course, this should be stroke style, like so. But now it's also possible to extend this line. So we could, for example, say ctx.line2. And let's, for example, say now we want to go down. So we'll stay at x 200, but we'll move a little bit further down. So we increase our y value to 200. Now let's also try to move to the left again. So we can just say ctx.line2. We need to decrease our x value, so 100, and y will be 200, like so. And of course, to create a rectangle now, we could just say ctx.line2, and we need to go back to our initial value, so 100, 100. And this would be a rectangle essentially. So this is how you essentially create a line. You could also create another line by saying ctx.beginPath once again. Let's say ctx.moveTo. Let's start at 200, 500 for example. And let's say ctx.line2. Let's go to 200, 700. And let's just use ctx.stroke, like so. So now this created another line, or a new line. And you can create a lot of cool stuff using that, but feel free to experiment a little bit with that. And of course, again, if you wanted to change the color for our second line, you could just use ctx.stroke style of yellow, for example. And from that point on, everything would have a yellow stroke style. Of course, shadow blur would work as well. So ctx.shadow blur of 20, for example, and ctx.shadow color of yellow, like so. And now we will also have a blur. And maybe 20 is a little bit too much, so let's use 5. And you can see we have a slight blur right here. Now let's also try to create a circle, for example. And in order to create a circle, we should again use a path. So ctx.beginPath once again, like so. Let's also define a color. Let's say white. So ctx.stroke style is going to be equal to white, like so. And now to define our circle, we have to use ctx.arc. So to sum up again, fill rect to create a rectangle, move to combined with line2 for a line, and ctx.arc for a circle. So you see the syntax is pretty similar for all of those elements. And you can already see we need a lot of different elements for our circle. So the first one is x, then we have y. So this is the offset on our x and our y axis again. Then we have a radius for our circle. We have a starting angle, an ending angle, and counterclockwise. So whether the circle should be drawn counterclockwise or not. And this is a lot easier than it looks like. So for the x value, we could again use an offset of 100 and 100, like so. A radius of 50, for example. If you want to create a full circle, you should usually start at 0 degrees for the start angle And to get a full circle for the end angle, you will usually use 2 times math.pi, like so. Now we also need to define counterclockwise, and this is going to be false, because this doesn't really matter for us. And now let's use ctx.stroke, so we can see our circle. And again, this here should be stroke style, of course. So now we are seeing our circle. So again, this here's the starting angle, and this here's the ending angle. And to get a full circle of 360 degrees, we need to say 2 times math.pi. So to only get half of it, we could just say math.pi, like so. So as a starting angle, we could of course also define something else. So we could also as a starting angle define math.pi, for example, like so. And as the ending angle, 2 times math.pi. So that is up to you. And of course you could also say 1/4 and so on. So you get the idea. But usually you want to have a full circle, so you just use 0 and 2 times math.pi. Again, you could also fill a circle, so I could also say ctx.fill style is going to be equal to white. And now we can also fill our circle, so we can use ctx.fill followed by those brackets, and now we filled our circle. So that is possible as well. We could also use a different color, so we could say this here is going to be yellow, and the stroke is going to be white. And now we can also define the thickness of our line, so of our border, by using ctx.line width being equal to 5, for example. And you can see now we have a thicker line. This could also be 10, that's up to you. But you already see you can create a lot of cool effects by doing so. So I could also just say the radius is 20, for example, or 10, maybe a little less stroke. And if you would now have a lot of those circles, I think this could already look pretty cool. So there exist a lot of different shapes, but I think those ones are the most important ones, and you'll probably most of the times use only them. So now I want to introduce you to a very important concept, and that is the concept of classes. Of course you could create a circle like this one, the way we did it up to this point, but there's also a much better way, and especially a way that we'll need a lot later on. And that one is a class. So we could just say we want to create a class of circle, for example, like so. And now we could create a constructor to construct a circle essentially, like so. That one accepts a couple of parameters, and we need to initialize that one. So this is just a normal JavaScript constructor essentially. And this constructor will be called to create objects of the circle class. So later on, we can use this class blueprint to create as many objects as we like. So this blueprint here defines how every single circle should be, and then we can create different circles. So circle 1, circle 2, circle 3, and so on. And every single circle can now have a different radius, a different x position, a different y position, a different color, and so on. So I think you get the idea. And when using the constructor, we define all of those properties. So all of those properties that should be different for every single circle. And the first one is of course probably our x value and our y value. Maybe every single circle should also have a different radius and maybe also a different color, like so. Now, since this is not a JavaScript course, I'll not explain this too much, but we are just going to say that this.x is going to be x, this.y is going to be y, this.r is going to be r, and this.color is going to be color. So this refers to the object that we're later on creating by using this circle constructor. And those individual values just refer to the parameters that will pass to every single circle object. So let me show you. Let's create a circle 1, for example. That one is going to be equal to new circle. So we create a new circle. And now for that circle, we could use x position of 100, y position of 200, radius of 20, and color of white, for example. So that is totally valid. And now we could also have a second circle, so const circle 2 is equal to new circle. That one will sit at position 200, 400, radius will be 50, for example, and color will be yellow, like so. And you can see we already created 2 different circles. We are not able to see those circles yet, but those circles have different properties. And this always refers to the object that has been created by using this constructor. So for this object right here, this refers to this object. For this object, this refers to this object. So for this object, this.x is equal to 100, this.y is equal to 200, this.r is equal to 20, and so on. And for the second object, this.x is equal to 200, this.y is equal to 400, this.r is equal to 60, and this dot color is equal to yellow. So I think you get the idea. And now we can use this when creating methods, for example, to always refer to the object. So I can, for example, create a draw method that we'll use to now draw this circle, like so. And let me just console.log this dot color, for example, for you. And now we're just going to call circle1.draw, for example, so the draw method. Let me inspect, so right click, inspect, and you can see we're getting white. So for our circle1.draw, so this color is going to be white because that was the color that we've passed. And for circle2.draw, we should get yellow because yellow is the color for our second circle. So I think you get the idea. We now have a method that behaves different for every single object. So let me close this. And now let's actually draw something onto our screen. So instead of just console.logging this.color, we can actually just do the stuff that we've done previously. So we're going to begin a new path for every single circle. So ctx.begin path, like so. We want to set the color, so the stroke style, to the color that we've passed right here. So ctx.stroke style is going to be equal to this dot color, like so. Now we want to create our circle. So let's say ctx.arc. We have to pass x value. X value is this dot x. Y value this dot y. Radius this dot r. Starting angle is going to be 0 for every single circle. So I'll just hardcode that one. End angle is going to be 2 times math.pi. Because all my circles should just be perfect circles, so that is fine. And counterclockwise is going to be false. And now I'll also say ctx.stroke right here. And you can see we now printed or drew our two circles. We drew our small circle and our big yellow circle. So I think you get the idea. By using objects, we can now easily create hundreds or thousands of objects by just using one single class blueprint. I could just create more and more circles over and over again. So I could create a third circle, 400, and so on. And now I could say circle3.draw. Doesn't matter, you get the idea. But maybe that's not what I want to do. Maybe I want to create hundreds or thousands of circles, and writing this out 1000 times would probably be really repetitive. So I'm actually not going to do that. Instead, I'll use a for loop. So let me define a for loop. So I could say for, I'll initialize a variable I, for example. So let I be equal to 0. I'm going to repeat a task as long as I is less than 100, for example. And I'm going to increment I by 1 for every single iteration, or after every single iteration. And for now, let me just create a new circle every single iteration. So I'll just say const circle is equal to new circle. And now I need to insert a couple of values right here. So of course I could hardcode those values. So I could say 100, 100, 30, and yellow, for example, like so. And now I could just call circle.draw. And you can see this would be an option, but we're not seeing more than one circle because at the moment all of those circles are stacking. So we'll draw all of those 100 circles on top of each other. So we somehow need to be able to get those values right here randomly. So let me start to create an x value. So const random x, for example, could be the variable name. And let's say this here is going to be equal to math, like so, dot random. Math.random will create a value between 0 and 1. So let me actually show you. Let me save this. Let me use this as an x value, like so. And at the moment, we cannot really see anything because, of course, a gap between those circles of 1 is probably not enough. If I would scale that one by 100, for example, though, you can see that we're now getting an offset. Because now we're getting a value between 0 and 1, so probably 0.5, 0.4, 0.2, and so on. And then we scale 0.2, for example, by 100, which would give us 20. We would also scale a circle with 0.9, for example, which would have an x value of 90 then, for example, and so on. So I think you get the idea. But of course, we want to display our values within our entire canvas. So we should say times canvas.width, like so. And you can see now our circles are essentially everywhere. They are spanning over our entire canvas. Because imagine if we're getting a value of 1, for example, for math.random, times the canvas width, which could be, for example, 700 at the moment, then we say 1 times 700. So we draw a circle right here at the end. If we're getting 0, for example, for math.random, then we say essentially 0 times 700 and we get a circle right here at the left. And everything is essentially in between. So 0.5 for math.random would essentially give us a circle right here. So that is how this works. But essentially, random x always defines the center of a circle. So let me show you. So at the moment, we're essentially saying that the center of a circle, for example, if you have math.random of 0, is going to be right here. So this is now the center of our circle. But now our circle also has a radius. So once we draw it around the center. So right here. And of course, we then have this overflow right here. Because our circle starts at the absolute left of the screen, but the circle itself, because of the radius, goes outside of the screen. So in order to fix that, we could say that we want to use math.random times the canvas width, but we don't want to go to the absolute end of our canvas. We actually want to stop one radius before the end, so we are never getting outside, and we want to start one radius after the beginning. So we'll always just add one radius to the beginning, so we just say that we'll add a radius. So let's create a radius variable, so const radius is going to be equal to 30 for now. So let's just hard code this. And let's say random radius, for example. So random radius is going to be equal to 30. Now we'll pass random radius to our circle right here as a variable. And we just add random radius right here. And you can see no circle right now goes outside of the image, but we have a lot of them going outside of the right of our image. So in order to fix that, we could say that we subtract radius or our random radius from our canvas width, like so minus random radius. But actually we should subtract our random radius twice. And the reason for this is that we'll add it once later on anyways. So let me draw this for you because this can be a little bit confusing. So we're saying take up all of the canvas width essentially, like so. So that is the canvas.width at the moment. Now we're going to subtract our radius, so the radius of the circle twice. So we're getting here and here essentially. So those are two radiuses at the moment. So we subtract that. So we only draw at this point in time our circles from this point to this point. So essentially at this point in time, the last circle will be here. But the first circle will probably still be right here. So we also add random.radius afterwards. So the first circle will now be here because we added random radius again. And the last one will now be here because we also added random radius again. So that is what the formula actually does. So I hope you understand that. But now we can of course also randomly generate our random radius, and we should also do so if we want to use a random radius. So we could just say math.random again, like so. And now we have all those small circles. So all of those circles now are between 0 and 1. But we could also scale it. So we could scale it by 30, for example. And now if we go at a small math.random value, we will have a small circle or a small circle radius. Otherwise, we will have a pretty big circle radius. And this formula right here ensures that our radius will always be on screen, no matter the radius. But now we can do the exact same for our y value. So let's do that. Let's create a variable const random y, which is going to be equal to math.random again. And again, let's multiply that with our canvas dot height in this case, because we want to have them on our y-axis. So the height is important here. And now let's also use minus 2 times random radius plus random radius. So the principle right here is essentially the exact same. And now we can use random x instead of hard coding 100 right here. And you can see now we have all of those circles on our screen. Now we could of course also create our color randomly, for example. And let me show you how this works. We could, for example, create a colors array. So const colors is equal, and this will store a couple of random colors. So maybe yellow, maybe white, maybe blue, and maybe red. And this right here will actually look terrible, but you'll get how this works in a second. And now we want to access an element of this array. And if you know about JavaScript, we could access the first element, for example, by saying colors of 0. The second one by saying colors of 1. The third one by saying colors of 2. And the last one by saying colors of 3. If we would now, for example, just use the length, so colors dot length we will get the value 4. So this here is going to be equal to 4. If we would now use math.random, for example, we get a value between 0 and 1. And if we now multiply math.random with our colors.length, we will get a value between 0 and 4. But actually, math.random will give us a value between 0 and 1, but 1 excluded. So we'll never get 1. And therefore, if we're going to multiply the highest value, which is going to be something like 0.99, with 4, we will get something like 3.96, for example. So that will be our highest value. And if we are just going to use math.floor now to round it down, we will always get a value between 0 and 3, randomly essentially. So I hope you get the idea. So now we take math.floor of math.random, so a random number between 0 and 1, but 1 excluded. And now we'll multiply that with our colors.length essentially. And now we'll always get a value between 0 and 3. And now we could, for example, access colors of this random value right here. So we could just use this right here and put it in here. And now let me console.log this color for you. So console.log that right here, like so. Let's go to inspect. And you can see we're getting blue. Let me reload. White, yellow, and so on. And if we now do this for every single iteration, we'll get a random color every single time. So I could just say const random color is equal to this right here. And then I use random color instead of yellow. So let me actually save this random color. And you can see we have all of those random colors. And of course, you could also use like nicer colors right here. But you get the idea. Let's now understand animations. And let's just delete all of this right here. Because I think you understand it a little bit better if we get started from scratch. Like so. So we only have our canvas and our context at this point. Now I first want to create a circle so we can animate that circle. So let's create a circle. And let's not use a class at this point. Let's just create a basic circle. So ctx dot, and let's use a fill style because we want to have a filled circle. So fill style is equal to white. Now ctx dot begin path, like so, to begin a new path. And let's now use a circle. So ctx dot arc. For x, let's have 100, y 100, radius 20, for example, start angle 0, end angle math dot pi times 2, for example, and counterclockwise is false. And now let's just draw that one. So ctx dot fill, like so. So now we're having the circle right here. And now I also want to animate that circle. So let's create the animation. To animate that one, we could create a function, and that one could have the name animate, like so. And now within this function, we are going to call request animation frame, like so. And that one is a built-in function. And that one expects a callback, and we'll pass our animate function to that callback. So how does this work? We are now going to call the animate function right here. That one says execute whatever we have within this animate function. Within this animate function, we are going to call this method right here. And within this method, we'll have our animate function as an argument. And this method right here will now again call the animate function. So we call this function again. This function will again call this function, which will again call this function, which will again call this function. So you can see we have an endless loop right here. So let's, for example, just console.log, hey, let me go to the console. And you can see we're getting hey over and over again. So this is basically going to print this forever until we close this page. And this is great because now we can animate that one for every single tick. So every single tick, for example, we could change the position of this circle right here. So let's try this. So within this animate method, let's, for example, just create a new circle every time. So let's say ctx.begin path, like so. We're going to create a circle. So ctx.arc, let's use 100, 100, 20, 0, math.pi times 2, for example, and false. And now let's just use ctx.fill. And this will now draw our circle over and over again. And you see this one looks pretty weird already. But it's not really moving at this point in time because we just draw the same circle all of the time. But now we could, of course, also have a variable, so let x position be equal to 100, for example. So by default, x position is now 100. But now after every single iteration, we could just say x position plus equals 1. So we just increment x position by 1. And you can see now our circle essentially starts to move to the right. But this here still looks pretty weird because we never delete our old circle. So our old circle will always be there. And in order to clear the old circle, so clear whatever we had before, we can use ctx.clear rect, for example. This will clear the entire canvas. We need to define an x coordinate and a y coordinate, and this is usually 0, 0. And then for the width and the height, you just use the canvas width and the canvas height because you want to clear the entire canvas. So canvas dot width and canvas dot height, for example. And you can see now our circle moves from left to right. And after every single frame, we are first of all clearing the old frame, and then we are going to draw a new circle. So this is how this works. At the moment, I don't really like this animation though. And I don't really like the fact that we're using create right here without a class. So I'm going to change that first. So let's create a class circle. And since we already know how this works, I'm going to go over this a little bit faster. We first need our constructor. We want to have x. We want to have y. We want to have a radius. And that should be it for now. So let's say this.x is going to be x. This.y is going to be y. And this.r is going to be r. And now we want to draw our circle. So let's define a draw method right here. And we're just going to say ctx.begin path like so. We want to create a circle. So ctx.arc. As next value, we want to use this.x, y, this.y, radius, this.r, start angle is going to be 0, end angle is going to be 2 times math.pi, and this is going to be false. And now we'll just say ctx.fill, like so. Now I'm going to create a new circle, so const circle is equal to new circle. I want to use 100 for x, 100 for y, radius 20, and that should be it. And now within our animate method, I can just use circle.draw, like so. At the moment, we're not seeing our circle because our circle does not have a color. And now, of course, I could just say that ctx.fill style is going to be equal to white, like so. But since we'll have a lot of circles later on and all of them will have the same color, for now I could just say that ctx.fill style is going to be white, and I'll just define it right here for all of the upcoming circles, like so essentially. So let's move this down so this looks a little bit better, and there's the effect that we're having. But now I also want to update our circle every time we essentially animate it. So I'm going to create an update method, so update. And that one is essentially responsible for moving our circle. And this could be the variable name x movement, y movement, and so on. But usually you also just say dx and dy for movement into the x direction and movement into the y direction. And now, of course, we need to say this.dx is going to be equal to dx, and this.dy is going to be equal to dy, like so. And now we need to say that we want to move our circle into the x direction by dx every single time we call our animate method, and into the y direction by dy every time we call our animate method as well. So we could just say that this.x will be equal to this.x plus dx. So plus equals dx, for example. So this.dx. And the same for y. So this.y is going to be equal to this.y plus this.dy. So this is the movement speed essentially, and this here is the position. Let me save this, and let's also say 4 and 4, for example. And now we also need to call the update method. So we could say circle.update, like so. And you can see our circle is now moving. Let me decrement the speed right here. And you can see we're having this slowly moving circle. So just to make this clear, this.x will always hold the position, the x position. And this.dx will always hold the speed at which we change the x position. And the same, of course, for the y-axis. And of course, it's not mandatory to have this.x and this dot y, you could also only change this dot y or only change this dot x. Like so, we would only change this dot y, and like so, we would only change this dot x, so the x position. So that is up to you. And of course, you could also define pretty much any logic you like right here, and all of this would be fine. But now I also want to show you how you can make this circle bounce off the edges, because at the moment it's just going to the right bottom, and at some point it just leaves the screen essentially. So how could we change this? We could, for example, check if our x position is currently below our screen height. So let me demonstrate that. So this here is the entire height of our canvas, for example. And now we are slowly but surely moving our ball to the bottom. And we could, for example, say if this dot y in this case, so if the y position of our ball is greater, so if this right here, this position from top to our ball is greater than our canvas height, then we're obviously outside of our canvas. And under those circumstances, we want to bounce off essentially. What does bounce off mean? This just means that we reverse the speed essentially. So at this point in time, our speed essentially goes to the bottom. So we're moving to the bottom by 1 pixel every single time we call this animate method. And if we reverse this dx or dy variables for x and y, then of course we will go into the opposite direction like so. So I hope you get the idea. But let me show you how this works in code. We could first say, or we could first check if this dot x, for example, or this dot y, doesn't matter, it works the same for both directions. So if this dot x is greater or equal to canvas dot, and for the x-axis, of course, we should use the width, so canvas dot width. If that is the case, then we're going to inverse this dot dx. So this dot dx is going to be equal to minus this dot dx. So let me save this. And you can see our circle slowly moves to the right. And now it should actually at some point bounce off. And now we could do the exact same for our y-axis. So if this dot y is greater or equal to canvas dot height under those circumstances, because we are referring to the y-axis, then we want to say this dot dy is equal to minus this dot dy, like so. Let me also increase the speed a little bit because this is like really slow. And you can see now it starts to bounce off. But we still have the same problem at the left and at the top. Because of course, at the left, this dot x is going to be 0 or less than 0 essentially. And at the top, this dot y is going to be 0 or less than 0. So we should also check whether this dot x is less or equal to 0, because then we also want to reverse the direction. So this dot x is less or equal to 0, for example. And of course, the same should work for our y-axis. So we should also say, or this dot y is less or equal to 0 as well. And now it should always bounce off. So what we're essentially saying right now with the first statement is, if our x position, so the position of our center of the ball right here, for example, is greater than the width of our canvas, so greater than this essentially, then we change the movement direction from there, so from downwards to upwards. Next up, by using the second statement, we are essentially saying if our ball, so if our ball, for example, sits right here and is less or equal to 0, so if that is the case, then we're also going to reverse the direction from essentially here to here. So from upwards to downwards. And of course the same goes for the y-axis. But now something that is important is that x and y always refer to the center of our ball. But as you can see, it still looks as if the ball slightly goes out. And the reason for this is that, of course, we only check for our center. But actually we should probably reverse the direction once our center plus the radius hits an edge. So if our ball essentially is sitting right here, we then already want to reverse the direction. And in order to do so, we can just subtract the radius, so this dot r, from our canvas width. And of course the same goes for the height. So right here we can just do the same, and this works as well. And you can see this works for the side, but this does not work for left and top at the moment. So right here we still have this problem, because of course this is less than 0. So we should actually just say once this becomes less or equal to this dot r, we also want to reverse. So let me replace that. So we should also reverse this, and now we should get the right effect. And of course, the reason for this is that once essentially our point gets to this point, and only the radius is essentially left to the side, then we want to reverse the direction. So I hope you understand the idea. And now, of course, that we have this, we could also use multiple balls and create as many as we like. And in order to do so, we can, for example, create an array. So let circles be equal to an empty array for now. And now we want to use a for loop to create a lot of different circles. So for let I be equal to 0, as long as I is less than 100, for example, we want to increment I by 1, like so. And for every single iteration, we want to create a new circle. And we want to store the circle inside of the circles array. So let's say const circle is equal to new circle, like so. And of course, we need values like x, y, dx, dy, and r. And I can again randomly generate those numbers within a certain range. So now let's just randomly generate all of those values within a certain span. So first we need an x value. So const random x, for example, is equal to math.random. And again, we want to have those values. So we want to have our x value within our canvas. So again, we say times canvas.width, like so. But again, we have to say canvas.width minus 2 times our radius. We don't have our radius yet. So let's say const random r is going to be equal. And let's just use math.random. And let's have a radius between 0 and 15, for example. And now we just say times random r. And let's also add random r. So just the same formula that we've previously used. And now, of course, the exact same for random y. So const random y is equal to math.random, like so, times, and right here we have to use canvas.height minus 2 times random r plus random r, like so. So now we have the x, the y, and the r value. We also want to generate the x and the y, so the speed on the x and the y axis. So let's say const random dx is equal to math.random, and let's keep this value within a range of 0 to 5, for example. So 0 would be the slowest and 5 would be the fastest. Const random dy could be the exact same, so math.random times 5, for example. And now let's just use all of those values for a circle. So random x, random y, random dx, random dy, random r, like so. So this here is a circle now, and now let's just push this circle into our array. So circles dot push, and we push a circle into the circles array. And now after we've executed this entire queue, let me just console.log the circles for you so you understand how this looks. Let's go to our console, and we are getting the error circle is not defined. So actually we just need to remove them right here, like so. And now you can see we're having this array of circles. So all of those circle objects. And you can see we're having x, dx, dy, and so on. But we're actually getting not a number for a lot of them. And the reason for this is that this here is of course a function, so we should also call that. And now let me look at this again, and now we're having numbers for all of those values. So dx, dy, r, x, and y. So every single circle has those values. And those circles are random within a certain range, essentially. And range is of course the range that we've defined right here by using those scalars. And now we can just go over this array right here within our animate method and just draw and update every single circle right here. So every single one of those circles for every single tick of this animate function. So circles dot for each, we are getting one circle for every single iteration. And now for every single circle, we can just call circle dot draw and circle dot update, for example, like so. And now you can see we're getting all of those effects right here. So all of those circles who have all different sizes are moving on our screen. And I think this here is already a pretty cool effect. Now a problem that you might spot is that right here at the beginning, all circles move into the exact same direction. And therefore, for a short time, it looks pretty weird until everything is basically stable. But we can also fix that. And the reason for this is, of course, that by default, random dx and random dy is always positive. So how could we fix this? If you think about math.random, it will generate a value between 0 and 1. So now I could just go ahead and say math.random within brackets minus 0.5. And why would this work? Let me also do the exact same for dx. So minus 0.5. And you can see now this looks perfectly random. And the reason why this works is that if you get a number of 0, for example, this is going to be minus 0.5 times 5 minus 2.5. If you get a value of 1, then you would get a value of 0.5. So by using minus 0.5, this does not go from 0 to 1 anymore, but this instead goes from minus 0.5 to 0.5. Because if you get math.random of 1, minus 0.5, you get 0.5. And if you get math.random of 0, minus 0.5, you get minus 0.5. So this also alters the direction essentially. But now we still have one more problem. And the problem is that once we resize, so once we open our browser, you can still see we still have the same canvas width. And the reason for this is that only when we reload our entire page, only then the canvas will get the entire width and height of our window, because only then we are executing this file right here, and therefore setting the canvas width and height. But we can change that by, for example, saying that we first of all want to respawn our circles every time we resize the window, and we also want to reset canvas.width and height every time we resize the window. And actually there exists an event listener in order to do so. So we can just go ahead and say that we'll add an event listener to our window object, so window.add event listener. We want to call this event listener every time we resize our window, so every time the user essentially resizes his browser window. And under those circumstances, we want to call a callback function, for example. And within this callback function, I'd like to initialize the circles and the browser width. So I'm just going to say that I create a function, so const init being equal to this entire for loop here, for example. So let me just copy and paste this in here. So this for loop will essentially initialize all of the circles once we call it. So let me call it right here before animating, so init. So I can see this initializes now all of the circles. But now every time I call this init method, I also want to say that canvas.width is going to be equal to window.innerWidth, and canvas.height is equal to window.innerHeight, like so. So now every time I resize the window, the canvas should take up all of the available space. And in order to do so, we need to call the init method every time right here when the user resets or resizes his browser, so init, like so. And you can see now when I'm going to resize the browser, we have the same effect, so this still works. But we also see a problem, so let me show you. Right here, every time I resize the browser, we are going to call the init method again, and we get more and more circles. So let me do this a couple of times, and I think you already get the idea. We're getting more and more circles because we're not deleting the old circles, but we're always adding new circles by calling this for loop here once again. And of course, one of the possible solutions would be to just take this for loop and place it outside of this init method. And now we still would have the same effect. But you can see this here looks weird. So once I resize the browser, it takes a little bit of time for all of the circles to go over and take up all of the available space. So maybe you want that, and then that is fine. But maybe you also want to immediately resize or respawn all of the circles, and then that is of course not fine. So in order to fix that, you can just, when calling init, so when resizing essentially, also reinitialize all of the circles. But before doing so, we just set circles to an empty array. So we clear all of the old circles and then generate all of the new circles. And now, every time I resize the browser, we're just calling init again and therefore generating new circles that will spawn according to the new browser or canvas width and height essentially. It's your favorite NPC, and today we're going to build this colorful particle effect that will increase the circle sizes once the user hovers over them, using HTML, CSS, and JavaScript. By the end, you'll have the exact same effect and you'll be able to change colors, amount of circles, radius, and more with just a single click. So let's get started, guys. So let's get started from scratch. First of all, we need an HTML file, so I'm going to create an index.html. I'll also need a CSS file, so let's have a style.css file, and a JavaScript file, so an index.js file. Let's create a basic HTML template, like so, and within this template, let's link our CSS and our JavaScript file. So link :CSS to create the CSS file or to link the CSS file, and script :source to link our source file, which has the name index.js. We'll also add the def attribute, which again tells HTML to pass this script right here after all of the HTML code has been parsed. So this script will be executed last. In order to use a canvas, let's use a canvas HTML element right here. And let's right click the page, open with live server, like so. So this is our page currently, and we're not able to see our canvas. So let's change this by giving this canvas an ID of canvas, for example. And now I want to get this canvas within JavaScript. So const canvas is going to be equal to document get element by ID canvas, like so. I also want to give this canvas a background color. So within CSS, I'll say hashtag canvas. I'm going to choose a background of black. And now we have this black canvas. So this is currently this canvas. I also want to reset all of the default HTML styles that lead to this weird gap right here. So I'm going to use the universal selector in CSS. And I'll say margin is going to be 0, padding 0, and box sizing border box, like so. And this here has nothing to do with canvas. This is something that you should pretty much do on every single website, to just reset the default HTML styles. But now I also want this canvas to take up all of the available space of this page. So essentially the entire window width and height. And in order to do so, we should use JavaScript. So we'll say canvas.width. So the width of this canvas right here is going to be equal to window.inner width. So to the inner width of this entire window, like so. And the height, so canvas.height is going to be equal to window.inner height. So to the height of this entire window. You can see we also have those weird scroll bars. We can get rid of them by using CSS, by saying our body should have overflow of hidden, like so. And now we want to draw a couple of circles on this page right here. So we should use JavaScript for this. First of all, we need to create a context. So const ctx is equal to canvas.getContext, like so. We want to create 2D because we want to have a two-dimensional context essentially. And this context object now allows us to draw our circle and pretty much everything we want to draw. Now, in order to create circles or a lot of circles, let's have a class circle that allows us to create a lot of circles later on from this blueprint. We want to have a constructor that will allow us to construct a lot of different circles. And every single circle will have an x value, a y value, dx, which is the speed in the x direction, dy, which is the speed in the y direction, a radius, and we also want to have different colors. And you'll understand later on how this works. So this .x is going to be equal to x, this .y is equal to y, this .dx is equal to dx, this .dy is equal to dy, this .r is equal to r, and this .color is equal to color. Like so. And now we can create a new circle by creating a variable. That one could have the name circle, for example, and this will be our object or hold our object in a second. This is going to be equal to new circle. And now let's create a new circle at the x position 100, for example, y position 100. Speed into the x direction could be 4, doesn't matter for now. Y direction maybe 2. Let's have a radius of 20 and a color of white for now, like so. But as you can see, at the moment we are not able to see the circle. So we should also, for every single circle, have a draw method. So let's have draw as a method right here. To now draw a new circle, we should first say ctx, so context dot begin path, to begin a new path. We should also define a color for our circle, and we can do so by saying ctx dot stroke style. This is going to be equal to this dot color. This dot color is going to be white for our circle. So the stroke style is going to be white. So we'll have a white border essentially for this circle. Let's also define the circle by saying ctx dot arc. We need to define an x value for the circle, so this dot x, a y value, so this dot y, a radius, so this dot r, a start angle, this is going to be 0, because we want to have a full circle, and the end angle is going to be 2 times math dot pi. So this here says essentially draw an entire circle, and counterclockwise should be false. Doesn't matter too much though. And now we need to call ctx.stroke to create our circle. I'm now going to call circle.draw, and this will draw our first circle. And now of course we could create as many circles as we'd like by just creating new circle objects. So this one could be at a position x of 200, for example, and this would just be a little bit further to the right. So a little bit further to the right on the x-axis essentially. But now I just want to create a lot of circles. So maybe 100, maybe 500, we'll see. And typing that out by hand is not the best idea. So I create a circles array. So let circles be equal to an empty array like this. And now I use a for loop to create a lot of different circles. So for let I be equal to 0, as long as I is less than amount of circles I want to keep going. And after every single iteration, I want to increment I by 1. And now I, of course, also need to create this variable. So let's say const amount of circles is going to be equal to 250. So we can change this later on. But at the moment, we repeat this for loop 250 times. So now, for every single iteration, we want to create a new circle. So we are going to say circles.push. So into the circles array, we want to push a new circle. So new circle. And we want to initialize the circle with a couple of values. But if I'm now just going to use the exact same value for every single circle, they will just all be on top of each other. So I also need to have a little bit of randomness in there. And let's do this. Let's start by creating a radius. So const random radius is going to be equal to math.random, like so. And let's multiply that one with a max radius variable. So if math.random is essentially going to be close to 1, our random radius is going to be super big. And if math.random is going to be close to 0, our radius is going to be pretty small. And max radius is essentially going to be the maximum radius a circle can have, because of course if math.random returns 1, then we get our max radius. So if max radius is 30, for example, then 1 times 30 is obviously 30. So const max radius. And for now, let's just use 20. We'll test this later on anyways. Now we also need the x values and the y values. And in order to make this work properly, again, I need random radius. So const random x is going to be equal to math.random, once again, so a value between 0 and 1. And now I want to multiply this one with our entire canvas width. So times canvas dot width, like so. But since random x defines the center of our circle, this would look as if a couple of circles are outside of the frame. So we also need to keep our radius into account. So canvas.width minus 2 times our random radius. And afterwards we add a random radius, like so. And now of course we have to do the exact same for our random y. So const random y is equal to math.random, like so, times, right here we need to use canvas.height minus 2 times our random radius again, and we need to add our random radius right here. Now we also need to define a velocity for x and a velocity for y. So we could just say const dx, or speed x, for example, is going to be equal to math.random. And let's just multiply that one with a speed x factor, for example, like so. We don't have this factor yet, so let's create this one. So const speed x factor is going to be 4. Let's also create const speed y factor. Let's set this to 4 as well. Doesn't matter too much. And now This here will create the speed on the x-axis, and this variable will create the speed on the y-axis. So math.random, like so, times speed y factor, like this. So math.random again can be between 0 and 1. And since our speed x factor is going to be 4, this will be close to 4 for math.random close to 1. And it's going to be really small, so close to 0 if math.random returns a really small value. So this here randomly generates a speed x for every single circle between 0 and 4 essentially. And the same for y at the moment. And now to our circle, we can just pass those random values. So the first one is our x value, so random x. Second one is y value, so random y. The third one is dx, so speed x. Then we have speed y, so speed y. Now we have a radius, let's use random radius. And for the color, let's just use white for now, but we'll change this later on as well. So this will now create all of our circles, but now we also need to draw them. So we create an animate function right here, which is going to be equal to this arrow function. And within this animate function, I'm going to call request animation frame, like so. I have to pass a callback function. I'll pass animate right here. So animate will call request animate frame, which will again call animate, and animate again will call request animate frame, and so on. So this will loop forever, like so. And now within this loop, I want to go over all of my circles. So circles dot for each. I'm going to get one circle for every single iteration. And for every single circle, I want to call the draw method right here. So draw. So I just say circle dot draw. And now I also have to call animate right here. And you can see we're having all of those circles. But at the moment, we're just stacking them on top of each other. We are not animating them yet. So that should be our next task. So I create an animate function, or to be precise, an update function, and I call that one update, like this. And now let me just change the x position for every single circle by dx, so the speed on the x-axis. So this dot x plus equal this dot dx. So we'll add the speed to x every single time we call this update method. And of course, we also need to call this update method. So circle.update, like so. And you can see now we're updating. But we're still keeping all of the old frames. So we should also reset the old frame and just print the new frame. So we can just say ctx.clear rect, like so. Let's use 0, 0. We want to clear everything within the width of our canvas. So canvas.width, like so. And canvas.height, like so. And you can see now we're getting this effect. But I also want to have a little bit movement into the y direction. So I also have to say this.y. And to our current position, to our current y position, we'll also add, for every single time we call this update method, this.dy, like so. And you can see now we're getting this movement right here. But at the moment you can see all of them move into the exact same direction. So all of them move to the right bottom. But we can change this by saying math.random minus 0.5. So now the biggest value becomes 0.5 and the smallest value becomes minus 0.5. So negative direction is now possible as well. And the same, of course, goes for the y value, so minus 0.5. And now you can see they're moving into all different directions, like so. But they're still going outside of the frame, essentially. So I want to limit the movement within the frame, and I want to make those circles bounce off the edges when they hit an edge. So I need to say, within this update method, whenever this.x is less than 0, for example, so if a circle goes out of the frame to the left, I want to reverse the movement. And of course, the same goes if this.x gets bigger than the width of our canvas, because then, of course, it's also outside of the canvas. So I'm going to check if this.x is greater than canvas.width. And if that is the case, then I want to say this.dx is equal to minus this.dx, so I reverse the direction. Or I'm also going to check if this.x is less than 0, because then it's outside of the frame right here, so at the left, like so. But now I also need to keep into consideration the radius, because this.x always refers to the center, so it looks a little bit weird, as you can see. So to keep that into consideration, I say greater than canvas.width minus this.r. And for less than 0, I can say once this becomes less than this.r, like so. And now this works. And now I need, of course, to do the same for our x values. So if this.x is greater than canvas.height minus this.r, or if this.y, and actually this here needs to be this.y, my bad. So if this.y is less than this.r, under those circumstances, I also want to invert this.dy, and now this.dy is equal to minus this.dy, like so. So I hope you understand how this works. So at the moment, this looks pretty nice, but we still have a bug where we can like resize the window, but our canvas is not resizing. So we should also resize the canvas every time we resize the window. So we should add an event listener to our window. So window.add event listener. We want to listen to the resize event. So whenever the user resizes the browser, we want to call this callback function right here. And I want to create a callback function. So every time the user resizes the window, I also want to resize our canvas. So I'm going to say const init is going to be equal to this arrow function. And now I'm going to say that canvas dot width is going to be equal to window dot inner width, and canvas dot height is equal to window dot inner height, like so. So this will resize the canvas whenever the user resizes the window. But now, of course, I also need to call this init function whenever the user resizes his window. So I'm going to call init right here, like this. Let me resize the window, and you can see it looks like this. But this here takes a little bit too long, in my opinion. So I also want to initialize all of the circles once again, once the user decides to resize his window. And in order to do so, I can actually just take this for loop right here. I can place it within my init method right here. And of course, I also need to call it when we first load this file, like so. So I can see this works. But at the moment, we're only creating more and more circles every time the user resizes his window. And of course, we do not want that. So we also need to clear circles every time we initialize. So we clear circles and then regenerate them. Otherwise, we will only get more and more circles. So circles is going to be equal to an empty array, like this. And now you can see this here seems to work on every single device. But now maybe we also want to have a different color for all of these circles. And in order to do so, I will use a couple of different colors. So I create a variable, const colors, that will hold all of our colors. And feel free to use the colors you like, but I prepared a couple of them right here. So I can also just copy the colors that I'm using right here. That's up to you, of course. And now for every single circle, I'm going to set a color. So a random color, essentially. So when creating the circle, we should actually pass the random color right here. So how can we create a random color? So const random color is equal. And of course, we can select a random color by getting colors of an index. So colors of 1, 0, whatever. So we could just create a random number between 0 and the length of this array. So I could just say math.random times colors.length. And since this here gives us a number between 0 and 1, but 1 excluded, so essentially between 0 and 0.99, we essentially get a number between 0 and probably 3.97, something like that, because we have 4 colors. Or actually we have 5 colors, so something between 0 and 4.96. So something in that range, or 4.95, doesn't matter, you get the idea. So if we are going to use math.floor on this number, we are getting the numbers 0 to 4. And now I can actually just use this for our random color right here at the bottom and set this equal to one of those colors. So random color now stores one of those colors. If I'm now going to use this one right here, you can see that we are having all of those different colors. And now I also want to have a different thickness for all of those lines. So I'm going to say right here, ctx.line width is equal to 2, for example. And of course, it could also be 3 and so on. So that is up to you. And actually, I'm going to use a different max radius. So maybe I'm going to use 13, for example. So now my circles are a little bit smaller, and I might use 15. And now I also want to create a shadow for those circles that has the exact same color. So I can say ctx dot shadow blur is equal to maybe 20, and ctx dot shadow color is equal to this dot color, for example. And you can see now we're having this blur. And let me set this to 10, for example. So I get the idea. Could be 15, that's up to you. So feel free to choose whatever color you like. But now, instead of clearing the rectangle after every single iteration, I can also keep the rectangle and only override it by filling it with a transparent form of black. So let me show you. So fill rect, for example. Let me clear this. And you can see we need an x value, 0 for example, y value, 0. The width is going to be canvas.width, like so, and the height is going to be canvas.height. And what is the color that I want to use to fill the rectangle? I want to use ctx.fill style to define a color, and I'll actually use RGBA of 0, 0, 0, 0.2, for example. And you can see we're getting this weird effect because now we're calculating all of the other frames before and only overriding the next frame with this fill color essentially. So you have to imagine it like this. We are drawing all of the circles, then we are calling animate again. We're filling the frame with this color, which is still slightly transparent. So we're seeing 80% of the previous frame essentially and drawing a new circle. But if you keep it like this, we will always have this weird color. So to get rid of this color, we essentially have to reset our shadow blur after every single drawing. So we have to say ctx.shadowblur is 15, then we draw our circle essentially, and then we have to say ctx.shadowblur is equal to 0 to reset it. And now we're getting this cool effect. So it's pretty important that you reset the shadow blur afterwards. And you can see this here is our effect right now. So this looks pretty nice in my opinion already. But now let's actually go one step further and let's make those circles scale up once we hover over them or once we are close to those circles. Let me draw this for you. So when I'm going to be here with my cursor, for example, I want all of the circles that are within a range of 30 pixels top, 30 pixels bottom, 30 pixels right, and 30 pixels left, for example, to get bigger. So I somehow need to check whether those circles are within a range of 30 pixels essentially, or 50 pixels, that's up to me, but I'm going to choose 40, 50, we'll see. So I hope you get the idea. This is my cursor, and now I'll check whether a circle is close to my cursor. If that is the case, then I'll scale it up. So let's do this. Let's start by first of all tracking our mouse position, and we can do so by creating an object, for example, that keeps track of our mouse position. So const mouse position is equal to an object. By default, we will have an x value that will keep track of our mouse position on the x-axis. That is going to be null by default, and y is also going to be null by default. And x tracks the x-axis and y the y-axis, of course. But now I can add an event listener to update my mouse position. So let me add this event listener, window dot add event listener. I want to add the mouse move event listener. So whenever we move our mouse, this event listener will be executed. And whenever that is the case, then we want to set this mouse position.x and mouse position.y values. So mouse position.x is going to be equal to an event, and we get this event by default when calling an event listener. And in this case to e dot, and let me actually show you how this works. So let me first of all console.log the e event for you, so the event for you. Let's inspect console, and you can see we're getting this mouse event, and this mouse event has a lot of properties. So this mouse object, something like client X, client Y, and you can see client X and client Y change every time we create a new mouse event, as you can see. So client X, client Y, and we need client X and client Y. So let's get this. So let's go back, and let's say mouse position.x is equal to e.clientx, and mouse position.y is equal to e.clientY, like this. And now we just need to compare our current position, so this.x and this.y, to the current mouse position. And if the element is within a range of 30 pixels, for example, then we are going to scale up our circle. So let me check for this within our update method. So I'll check if this.x minus mouse position.x is less than 30. Under those circumstances, we could just say that we want to increase the radius of our circle. So we can say this.r, and let's just increase the radius by 10, for example, for every single tick. And you can see now those circles are scaling up. But at the moment, this is obviously not too good because we're essentially scaling up forever. So we should define a max radius. So let's do this. So we already have the variable name const max radius. So let's say const max scale radius is going to be equal to 50. And we're going to check if this.r is less or equal to max scale radius. Only then we are going to scale the radius up, because otherwise we already reached the max. So this right now is the max. But as you can see, we're never getting back. So we're never getting back to the original radius. So I should also check, or I should also do something if this is not the case. So if we're not within this range. And under those circumstances, I want to say this.r minus equal 10, for example, like so. And you can see they're immediately getting out of the frame. And actually hard coding a value is not the best option. Something that is better is using multiplication, because this now depends on the previous radius and never gets to 0. Because of course, if you imagine if a circle, for example, only has a radius of 5 and then we are decrementing it by 10, this circle is obviously gone. If we're going to use multiplication and we'll only multiply it by 1.1, for example, and right here by 0.9, for example, then the radius will never be gone essentially. It will only get pretty small. But at the moment this still looks pretty weird, and the reason for this is that we'll only check whether this.x minus mouse position.x is less than 30. But of course, if a circle is to the left of our mouse, then all of the circles to the left essentially will be scaled up. And that is of course not what we want. We also want to check if this.x minus mouse position.x is greater than minus 30. Like so. And actually this here needs to be AND. So both those conditions need to be true, only then we are going to scale them up. But something that we also need to check is whether this.y minus mouse position.y is less than 30 and this.y minus mouse position.y is greater than minus 30, like so. So I think you get the idea. And at the moment, of course, we are not having a minimal radius, so we should also implement that. But actually, I do not want to have a minimal radius. I want to scale it back to the original size. So I also want to have this dot original radius, and I'll set this equal to the initial radius, so to r. And now I'm going to check if this dot r is greater than this dot original radius, and only if that is the case, only then I'll decrement the size of the radius, like this. So you can see this is now the effect. And actually I will use a couple more values right here. This here will be the max distance, for example. And now I'll use max distance and minus max distance right here. I'll implement this variable, so const max distance. Let's set this equal to 50. And you can see everything that is now within this radius will get bigger. And once it gets outside of this radius, it will get back to its original size. And let me also try to explain this here a little bit better to you. So what we're essentially doing right here with our first line is that we're saying if the position of our circle essentially minus our mouse position, so imagine we have a circle right here. So if the position from this circle inner point right here minus our mouse position is less than our max distance of 50, then we're going to increase the size. So imagine our mouse is right here, so this is the mouse, and if this.x, so the distance from here to here, minus the distance from here to here, is less than the max distance, so it's less than 50, or greater than minus 50, then we'll scale the circle up. So essentially, if our cursor has a distance of this distance to this distance, for example, then we're going to scale our radius, and we're going to do the same for this.y. So if a circle is within this distance and this distance essentially, then we scale our circle. And now you can see you can pretty much hover over all of those elements, and once a circle gets into a certain range, you will scale it up. And now I just hope that all of this was pretty much understandable, and I wish you a great day, of course. It's your favorite NPC, and today we're going to build this cool falling particle effect using HTML, CSS, and JavaScript. By the end, you'll have the exact same effect, and you'll be able to change colors, amount of particles, radius, and more by just using a single click. So let's get started, guys. Let's first of all create an index page, so index.html, and we also need a CSS file and a JavaScript file. So style.css and index.js. Let's now create a basic HTML template right here. Let's also link our style sheet and our index.js file within our index.html. So link :css to link our style.css file and script :source to link our index.js file. And right here for our script tag, we need to use defer to execute this JavaScript file after all of our HTML code has been executed. Now let's open this by using the live server like so. And this is now our blank index.html page. Let's output a canvas on our page like so. And we're not seeing this canvas yet, so let's change this by giving this canvas an ID of canvas. And let's style this canvas instead of our style.css file by saying #canvas. This one will have a background of black, like so. And let's also reset all of the default styles, so we're getting rid of this weird gap right here. So universal selector, margin 0, padding 0, box sizing, border box. So this just resets all of the HTML styles applied by the browser. So we're getting a clean basic layout. Now let's start to get this canvas right here instead of JavaScript as well. So const canvas is equal to document.getElement by ID, and we want to get our canvas by the ID. So this is now a reference to our canvas. And now we want to set the width and the height of our canvas. So canvas.width is going to be equal to window.innerWidth. So this says take up all of the width of the inner window, so essentially all of the width. And canvas.height is going to be equal to window.innerHeight, like so. And you can see we're having those scroll bars again. So let's fix that by going to our style.css file, body, and let's set overflow to hidden, like this. Next up, we want to draw on our canvas. And in order to do so, we first need a context object. So const ctx is equal to canvas.getContext, and we want to have a 2D context. And this returns an object. To be precise, we store this object in this ctx variable, and this ctx variable now allows us to draw onto this canvas. Let's create a class circle to create a couple of different circles. So class circle, and this will be the blueprint for a lot of circles later on. So we'll have a constructor to construct all of those circles later on. And every single circle will of course have an x value, so the starting x coordinate on our canvas. The same for y. It will have a speed into the x direction, so dx, a speed into the y direction, so dy. Every single circle will have a radius, and that should be it. Now we say this.x is equal to x, this.y is equal to y, this.dx is equal to dx, this.dy is equal to dy, and this.r is equal to r, like so. So this is our constructor. So now I can of course create a circle. So const circle is equal to new circle. Let's say for the x coordinate 100, y coordinate 200. So it should be around here. So 100 from the x-axis, 200 on the y-axis. For the speed, it doesn't really matter too much for now. Let's say for 4, radius of maybe 5 pixels. And let's do this. At the moment, we're not able to draw this circle right here. So let's do this now. We need to have a draw method in order to do so. For every single circle, we say ctx, so context.begin path, like so. Now let's also define the circle. So ctx.arc, we need an x value. That one will be the value that we passed right here. So right here. This will be passed as a parameter and be assigned to this.x. So we say ctx.arc is this.x for the x value, this.y for the y value, this.r for the radius. Starting angle will be 0, end angle will be 2 times math.pi. So we get a full circle like this, and counterclockwise will be false. Again, doesn't matter though. And now we just say ctx.stroke to create the circle. And now whenever we call circle.draw, we should draw a circle, but our circle at the moment is black, so we are drawing black on black, and of course this doesn't make too much sense. So we could, for example, say ctx dot stroke style, and right here we can define a color of white, for example. So this is our circle right now. But actually I want to have a fill style because I want to fill my circle. And if we're using fill instead of stroke, we should of course also say fill like this. So now we have a full circle. Pure white for the circle. I also want to use a different color though. So I use this RGBA value. So 255, 245, 220, and 1. So feel free to use the exact same one. And for now, let me actually just start by creating a lot of different circles on the screen. And actually, in fact, what I want to do now, I want all of those circles to start at the top right here, so outside of our frame, and I only want the speed to be slightly different for every single circle. So let me create a couple of different circles. So I'm going to use a for loop for this. So for, let I be equal to 0. We're going to execute this for loop as long as I is less than amount of circles, and I'm going to increment I by 1 for every single iteration. We don't have this amount of circles variable yet. That will define how many circles we create in the beginning. So I create const amount of circles as a variable, and I'll set this to 100, for example. So we start out with 100 circles. And now I want to create one circle for every single iteration and store that circle in an array. In a circle array, for example. So let circles be equal to an empty array. And now for every single iteration, I'm going to say circles dot push. I push a new circle into this array. So new circle. And every single circle needs an x, a y, a dx, a dy, and an r coordinate. And ideally, y is always right here somewhere. So outside of the frame, but x should be random, dx should be random, dy should be random, and r should be slightly random. So let's start by creating the r variable, so the radius. So const random r is going to be equal to math.random. So we create a random value between 0 and 1, excluding 1, and we'll multiply that with our max radius variable. We don't have that one yet, so let's create that as well. So const max radius is going to be equal to 5. So if our random r is close to 0 times 5 is still pretty small. So random r will be pretty small, so the radius will be pretty small. But if math.random is close to 1 times 5, this will be close to 5. So our random radius will be pretty big. So max radius essentially defines the max radius if math.random is close to 1. Now let me define the y value. So const circle y is going to be equal, and I want to start outside of the frame. So I'm going to start at 0, but I'm actually going to subtract the radius from it. So minus max radius, so that we're not seeing half of the circle within the frame at the beginning. And actually, of course, I can just say minus max radius because the 0 is unnecessary. Like this. So this is our starting point. Now I want to have a random x though, because I want to vary on the x-axis. So const random x is going to be equal. Let's use again math.random. We're getting a value between 0 and 1. I want to multiply with our canvas.width, like so. And in order to keep all of my circles within the width, in order to not have someone start outside of the canvas, I'm going to say canvas.width minus 2 times random r plus random r, like this. So this will be our random x value. Now we also need dy and dx. So we can say const random x speed is equal to math.random times max x speed, for example. We will create this variable in a second. Const random y speed is equal to math.random times max y speed, like so. So let's create those variables. I want to have a lot of speed in the y direction and not that much speed in the x direction. So const max x speed is equal to 4. Const max y speed is equal to 12, for example. And we'll test this later on, so it doesn't matter for now. And now I create a new circle by using, for the x value, random x. For the y value, circle y. For dx, random x speed. for dy, random y speed, and for r, random r, like this. So now I have all of those circles stored within the circles array, and now I could actually just print them out. So I could say circles dot for each. For every single iteration, I get one circle. And now, of course, I could just say that I want to draw the circle. So circle dot draw, like this. But at the moment, all of those circles are outside of the frame. This would, of course, change if I would say circle y plus 100. So this is how this looks like. This is the starting position with an offset of 100. So at the moment, the starting position is outside of the frame, but this is how you should imagine it. So in order to animate them, we of course need an update method, or pretty much any method that is responsible for animating, so for updating. So update right here could be the method name. And now for every single frame, I'm going to say that this.x is equal to this.x plus essentially this.dx, so plus the speed on the x-axis. And this.y is equal to this.y plus the speed on the y-axis, so this.dy. And now we should also call circle.update right here. But at the moment we are only running this once, so this does of course not make too much sense. But in order to change this, we can create an animate method. So animate is equal to this arrow function. And right here we call request animation frame. And within this animation frame we call animate. So this here will loop forever. Request animation frame will call animate. Animate will again call request animation frame, which will again call animate, and so on. So let's also call animate right here. And now within this function, let me just have circles.forEach, like so. And you can see this is now the effect that we're getting. But of course this looks completely weird, so let me fix this as well. At the moment, we are always going to the bottom right. But actually, at least the speed on the x-axis should be random. So it should be possible to either go to the left or to the right. And in order to fix that, we just say math.random minus 0.5. Because now if we're getting a value of 0 for math.random, will be at minus 0.5, so we go to the left. And if we get a value of 1, so the highest value of math.random minus 0.5, we're at 0.5. So that is how this works. Let me also clear this plus 100 because this is not necessary. And this is the effect that we're having right now. But you can see this here still looks pretty weird. So of course we could just say that ctx.clear rect, like so. And now we could just clear everything on 0, 0 for a width of canvas.width and canvas.height for the height. So we essentially clear our entire canvas after every single frame. And this will now result in this effect. But in my opinion, that's also not really what we're looking for. It would be a lot cooler if we would have a little line behind every single circle. So we could just blend it out. So we could essentially make that we still see a little bit of the last frame and so on. And in order to do so, we can use ctx.fill style first of all. This can be equal to RGBA of 0, 0, 0, 0.2. So this is a transparent black. And now for every single iteration, we say ctx.fill rect. So we want to fill the entire canvas. So 0, 0, canvas.width, canvas.height. So we essentially want to fill our entire canvas with a black color that is transparent. So 80% of the last frame will still be visible for the next frame, and so on. So in 2 frames, only 60% of this frame is visible, then 40, and so on. And actually this here should of course be fill rect, like so. And right here, I'm overriding ctx.fill style, which I set previously for all of the things right here to be white. So within every single drawing, I should just call ctx.fill style and set this to white. So now we're already getting this effect. I think this looks a lot better already. And actually, I think it would also be a little bit cooler if we would also have some random spawning when we first start the animation. So it does not have to start at the top right here, and it can also just spawn right here. And in order to do so, we can just go to our random x. We can just actually copy this code right here, paste it in here, like so. And right here for random y, let's say random y, and replace this, we can just use canvas.height instead of width, and this should fix the problem. And you can see this is the effect that we're getting. At this point, I also think that all of the items should respawn at the top once they leave the screen on the x or y axis. So I need to check, is our circle outside of the frame? And if that is the case, then I want to reset our circle to the top. And I should do that within the update method. So I should check if this.x is greater than the width of our canvas essentially. So if this.x plus our radius essentially, so our complete circle is outside of the frame, so plus this.r is greater than canvas.width. And actually this here needs to be minus this.r. So if our entire circle is outside of the frame, so it's outside here essentially, then I want to reset it to the top. So I just want to say then this.y is going to be 0. So I'm again starting here. But actually I want to subtract the radius, so minus this.r. So I'm essentially starting right here. So the radius is also outside of the screen. So I hope you get the idea. But I should also reset x. And actually it doesn't really matter. I can reset x to pretty much anything. But I can also just store the original x value somewhere. So I could just say this.original x is equal to x. And now I keep track of the original x value without ever touching that. And now I can just use this.original x to reset our x value. So this.x to our original x value. So this.original x, like so. So let's test this. And you can see a lot of them are getting back to the top right here. But I should also check whether the circle leaves to the left. So I can also check or this.x plus this.r is less than 0. Then I want to do the exact same. And you can see at this point this works as well. And now somehow this works because at some point all of the elements are leaving our canvas to the right. But of course we could also check whether our element leaves to the bottom. So you could also say or this.y is greater than canvas.height essentially. And of course we should again say this.y minus this.r. So we keep our radius into consideration. So now this here should work as well. And you can see, in fact, it does. But I think the radius of our individual circles is a little bit too big. So for the max radius, let me use 3, for example. For the max x speed, let me only use 2 or 3, doesn't matter too much. I think you get the idea. And for the amount of circles, I want to use 200. But I think the transparency is a little too much. So like this, I think it would look a little bit cooler. And of course, you can experiment with those values and that's up to you. And you could also create a random alpha value for every single particle. So all of those things are essentially up to you. Maybe max y speed could be 5 or 4 and 1. And now we're getting this effect. For the max radius, let me use 2. And I think something like this looks pretty nice. One problem that we still have though is that this here does not take up the entire width when we resize. So only when we reload, we're checking for window.innerWidth and window.innerHeight, and only then we are resetting. So every time we are essentially resizing the window, or the user resizes the window, we should also reset canvas.width and canvas.height. So let me add an event listener. So window.add event listener, I want to listen to the resize event, and whenever the user resizes, I want to do something. And at those circumstances, I want to create an init method. So this init method will run whenever the user resizes the browser or loads the page. So const init is equal to this. And whenever we initialize, of course, we want to check or we want to set our canvas.width to window.innerWidth and canvas.height to window.innerHeight, like so. And now whenever the user resizes, I want to set our canvas, so I'm going to call init, like so. And you can see now when I resize, we still have this effect, but you can see our particles do not take up the entire width, because initially we calculate them based on the initial canvas width. So whenever we resize our canvas, so whenever we resize the window essentially, we should also calculate all of those circles once again. So I'm going to delete this loop and I'll initialize all of those circles once again once we resize the canvas or reinitialize the width and the height. So let me save this. But now we don't have any circles because of course we also need to call it at least once when we start our file like this. So now this works. And now we reinitialize the circles every time we resize as well. So now we're having this effect, as you can see. But at the moment, we just create more and more of those circles every time we resize. And it's likely that you do not like this. So every time you initialize, you should probably first reset the circuits array to an empty array and then fill this array again based on our new width and height. And now we're getting this effect that looks good on pretty much all of the device sizes. And that is how you create this cool particle falling effect using HTML, CSS, and JavaScript. So now let me introduce you to gravity. And in our case, we want to create gravity for a square, for example. So we want to have a falling square that hits the ground, bounces off, but obviously gets faster towards the bottom and gets slower towards the top. So similar to a normal ball that falls on the ground. So I think you get the idea. But let's use a square to also practice how to use squares. So let's create a class, square for example, like so. We want to have a constructor. This constructor could have an x coordinate, a y coordinate, maybe also a falling speed that defines the speed at which our square falls. We want to have a width for our square and a height for our square. And now let's just say this.x is equal to x, this.y is equal to y, this.falling speed is equal to falling speed, this.width is equal to width, and this.height is equal to height, like so. And now, of course, we also want to draw our square. So let's create a draw method for this. So draw, like this. Let's first of all set the style, so the fill style. So ctx.fill style is going to be equal to white. And now let's also draw our square. So ctx.fill rect. We are going to start at an x value of this.x, y value this.y, w is going to be this.width, and height is going to be this.height, like so. And now we can just create a new square and test this. So const square is equal to new square. For the x value, let's just use 100, y 100. Falling speed could be 10, doesn't matter too much at this point. Width is going to be 50 and height 50, for example, like this. So let's save this. Let's also call square.draw to draw our square onto the canvas. And this is now our square. Now, of course, I would also like to animate this square. So I need to create an animate function. Const animate is going to be equal to an arrow function for now. And inside of this arrow function, we are going to call request animation frame. And within this request animation frame function, we call as a callback function our animate function right here, like this. And now, of course, afterwards, we should also call animate to execute it. And then this here will go on forever and ever. So just normal animation logic. Of course, we should also create an update method right now that we can call within this animate function. So update, like so. And right here, we want to move our y value by our falling speed. So let's just say this.y plus equal this.falling speed. And now within this animate function, let's first of all call our update method right here for our square. So for square.update and also the draw method afterwards. So I can just copy this line and paste it in here like this. And you can see now our square is essentially moving at a constant pace. So this is pretty similar to all we had before. We should also clear everything we had before. So we could just say ctx.clear rect. We're going to clear and start at x of 0, y of 0. We clear for a width of canvas.width and a height of canvas.height, like this. And now we have a falling square. But now we also want to check if our square hits the ground. And if that is the case, then we want to reverse the movement. So within our update method, let's also check if this.y is greater than our canvas height right here. So canvas.height. And actually we need to subtract our height. So minus this.height. So the height of our rectangle. And I'll explain why this works like this in a second. But first of all, under those circumstances, of course, we want to say this.falling speed is equal to minus this.falling speed. So we want to reverse our falling speed. And you can see now it bounces off. But let me draw for you why this works. So at the moment, let's imagine that our square is right here, for example. For a square, this.y refers to the top left corners. And now we're checking if this.y, so if this point, is essentially greater than our canvas height. So essentially right below our canvas. But now we subtract the height of our square, so essentially this height, from our canvas. And by doing so, we basically say our canvas does not really stop at the bottom, but instead the canvas should already end right here. Or at least the reference point for our square should end right here. So once this point essentially hits this line, we want to reverse the movement. So that is how this works. So pretty similar to the circle, but just a different reference point. But now I also want to increase the speed when falling. So I want to say that after every single iteration, I want to increase the falling speed. So this dot falling speed plus equals 1, for example. And you can see, now we already have this gravity effect. And let me first of all console log this dot falling speed for you, so you really understand why this here works the way it does. So this dot falling speed like so. Let's go to the console, so inspect, console, and you can see we have all of those numbers right here. And let me actually show you how this works. So we're starting at a falling speed of 10. We go to 11, 12, 13, 14, 15, all the way up to a max falling speed of 40. Then we're going to invert the falling speed, because we're saying this dot falling speed is minus this dot falling speed once we hit the bottom. And of course we are then at minus 39. And of course adding 1 to a negative falling speed will then increase the number, and at a certain point we'll get to a falling speed of 0 essentially. And once we switch from minus 1 to 1, we essentially automatically invert the movement direction. And that is essentially the point when we are going from our highest point, so from this point, back to our lowest point. So when we essentially change the movement direction. So now you probably might wonder why our square goes lower and lower, and at some point also might bug in the ground like this. So this is a problem that we can fix in a second, and I'll explain the reason to you for this. If you think about what we had previously, it's also possible that our square is sitting right here, for example. So it's essentially close to the bottom, but it's currently not really at the bottom. But during the next frame, it could be right here, for example, because we add falling speed right here to our y value. And we're going to check for this condition. For the previous frame, so for this square right here, this condition was false, so we are not going to invert the falling speed. And for this square right here, this condition is obviously true, because it's already outside of our canvas. So now we are going to reverse the falling speed. But now for the next frame, it would be possible that our square is a lot higher already, but it's still probably outside of the canvas, even though just slightly maybe. And then we're going to invert the falling speed once again, and of course this is going to bug once again. And of course this here would be a bug, because we do not want to invert the falling speed twice in a row, and doesn't make too much sense. And of course this here is more likely to happen once the falling speed is very, very little. And that's also the reason why this here usually happens at the end. So if I'm going to do this again, this will usually not happen in the beginning, but rather in the end. But of course this is nothing that we want. So every time we invert the falling speed, we also want to set this dot y equal to the absolute bottom essentially. So we move it to this line right here. Even if it's further down, we move it back up to the line, and then we start to adjust this dot y. So we can just say this dot y is equal to our canvas height essentially. But if I would do this, our point would essentially start at the bottom, so our square would be outside of the frame. So in order to fix this, I should again subtract this dot height, so the height of our square, and now this should fix the problem. And you can see it now does. Our square goes on forever and ever, and always ends at the exact same height. And of course we're going to increase our falling speed up to the lowest point. It's still going to be pretty high once we invert the falling speed at the bottom, but it's going to get gradually slower until we hit a falling speed of 0. And then we're going to invert the falling speed again, because we're adding +1 every time, and we're going back down. And of course we're starting slow and getting faster again. But now maybe we also want to make this here fall a little bit slower every time this here hits the ground. So we could also invert the falling speed and just add friction, for example. Doesn't matter how you call this, but friction would essentially reduce the height of a jump every time it hits the ground. So we could say friction of 0.1. So const friction is going to be equal to 0.8. And now this here jumps less and less every time it hits the ground. And of course you could also use 0.9 and then this would jump a little bit longer, but you get the idea, I think. And of course, using this value is up to you. And that is pretty much all you really need to know to understand how to use gravity with JavaScript and HTML Canvas. It's your favorite NPC, and today we're going to build this gravity particle effect that will create new particles once the circle hits the ground using HTML, CSS, and JavaScript. By the end, you'll have the exact same effect and you'll be able to adjust it by using a single click. So let's get started, guys. First of all, we need to have an HTML file, a CSS file, and a JavaScript file. So let's create an index.html, a style.css, and an index.js file. Let's start to have a basic template in our index.html by using the exclamation mark and pressing enter, for example. And now right here I'll have a canvas. I'll also give my canvas an ID of canvas, for example. Now let me also open this page with our live server. So open with live server. This is now our page. We're not seeing anything, but you can see if I have some text, this is how this looks. And this here looks pretty weird because of course our canvas takes up the rest of the space. Let me also link our style shield. So link :CSS and also our JavaScript file. So script :source. Let's link our index.js, and we have the def attribute right here that tells the browser to pass our script tag right here after all of the HTML code has been parsed. So our script will be executed last. Now let's also style our canvas in CSS. So let's target hashtag canvas. Let's give it a background of black, for example. And you can see we have those weird outlines. So let's also reset the default HTML styles by using the universal selector, margin of 0, padding of 0, and box sizing of border box. So this resets the default HTML styles applied by the browser. And that's pretty much all we need to do within CSS. So let's go over to JavaScript. So our index.js file. First of all, I want to have a reference to our canvas. So const canvas is going to be equal to document.getElementById. And I want to get my canvas because of course our canvas has the ID canvas right here. So this ID. So I'm getting this element and storing it in the canvas variable. Now I also want to define width and height for our canvas. So canvas.width is going to be equal to window.innerWidth. So to the width of this window. Now the same for the height. So canvas.height is equal to window.innerHeight. So the height of this window as well. Now we also have those scroll bars, but I want to get rid of the overflow. So I'll open CSS again and I say for our body, I want to have overflow of hidden, like so. Let me now also create a context object that allows us to draw onto the canvas. So const ctx, and to create the context we use canvas.getContext, like so, and we want to have a 2D context. So as an argument we'll pass 2D. And now we can use the ctx object to draw onto our canvas. In our case, I want to have a couple of circles later on and draw the circles onto the canvas, so I'll create a class for this as a blueprint for all of these circles. So class, circle, I want to have a constructor for those circles, so constructor. Every single circle will have an x position, a y position, a speed into the y direction, I'll call our speed into the y direction, dy, as well as a radius, like this. Now let's just say this.x is equal to x, this.y is equal to y, this.dy is equal to dy, and this.r is equal to r. So this is our constructor. Now we also want to draw the circle onto the canvas, so we need a draw method. So let's create a draw method for every single circle that we create later on. So draw, we first of all should define a fill color or a stroke color in our case. So let's say ctx.stroke style is going to be equal to white. So our circles will have a white stroke. Let me now also begin a path. So ctx.begin path, like so. Now I want to create our circle. So ctx.arc, for our x value we set this.x, for the y value this.y, for the radius this.r, for our starting angle 0, for the end angle 2 times math.pi. By doing so we create a full circle, and counterclockwise is going to be false. And now I want to say ctx.stroke like this. Let's just test whether this works by using a circle. So const circle is equal to new circle at 100x, 100y. dy doesn't matter for now, but let's just say for. R could be 20, and that should be it. And now I'm going to call circle.draw to draw our circle onto the canvas. And you can see we're having this circle, so this seems to work. But for our animation, we will need a lot of different circles. So I'm actually going to use a for loop to create a lot of circles and store all of those circles in a circles array. So let circles be equal to this array like so. And actually I'll have all my variables at the top, so right here. And now I'm going to use a for loop, so for let I be equal to 0, so that's the initial value. We're going to use this loop as long as I is less than our max amount of circles, for example. Or let's just use amount of circles, that's a little bit shorter. This here's the variable, I don't have this variable yet, so const amount of circles, and for now let's just create 20 circles. And for every single iteration, we'll increment I by 1. So right now, we create 20 circles, because that is our amount of circles. So now, for every single iteration, we need to create a circle and add the circle to our circles array. So circles.push. What kind of circle do we want to push into this array? A new circle, essentially, like this. And every single circle now needs x, y, dy, and r. And I want to create all of those values randomly within a certain range. I'm going to start by creating our radius randomly. So I'm going to say const random radius is equal to math.random. This will create a number between 0 and 1. But now I'm going to scale this number between 0 and 1. And our max radius size should essentially be our max radius size. And this is going to be a variable that I can later on change. So I'm going to say const max radius size. Max radius size is equal to 5. So if I'm going to get 1 for math.random, our radius will have a size of 5. If I'm going to get 0, the radius will essentially have a size of 0. So I think you get the idea. So this is our random radius right now. So I also want to have a random value on the x-axis. So I'm going to say const random x is going to be equal to math.random, and I'm going to multiply that with the width of our canvas, so times window, or in our case canvas actually, canvas.width like this. But I'm actually going to subtract the radius twice, so -2 times random radius plus random radius. And this right here essentially just makes sure that the circle stays within the frame. So also the radius stays within the frame. And now I also want to get a random value for our y coordinate, but I want our y coordinate to be outside of the screen. So actually right here at the top somewhere, and it should be slightly random. So I'm going to say const random y is equal to math.random like this. And right here we also need brackets. Actually, that was my bad. So brackets right here like this and brackets like this right here. And now I'm also going to multiply math.random times y start scaling, for example. And it's going to be a variable that I'll create right now. So const y start scaling, and let's set this equal to 500. So our starting position can at the moment be between 0 and 500, but actually I'll say minus math.random. So now it can be between -0 and 500. So our circle could essentially start here, but it could also start outside of the frame. So I think you get the idea. And now for dy, we can just say const random dy is equal to math.random times speed scalar, like so. And this here will decide the amount of speed that we'll have. So const speed scalar is equal to 5, like this. So if we get math.random of 1, our speed will be 5. And now for every single circle, we should of course also pass those values to the circle. So random x, random y. We also need random dy like this. And we also need random r, or radius. And now this should help us to create a couple of circles. Let's also create an animate function that helps us to draw the circles and animate them later on. So const animate is equal to an arrow function. And right here we call request animation frame and we pass our animate function. Again, this here will be an endless loop because animate will always call request animation frame and request animation frame will always call animate. So this is going to loop forever. And now we just have all of our circles and we go over every single circle by using circles dot for each. For every single iteration of for each, we get one of those circles like this. And now we can actually just call for every single circle circle.draw. And this should draw every single circle. At the moment, all of our circles should be outside of the frame. Let me remove this minus. And then we should actually see it. But I'm not calling animate yet. So I have to do this as well. And you can see those are our circles. I'm going to add the minus once again. So all of our circles are essentially outside of the frame. So this is essentially how this looks like. But this circle here is essentially going to start right here. So outside of our frame. And now we are drawing our circles. But now I also want to update it. So animate it essentially. So let's create an update method to animate our circles. So update. And I'm just going to say that this.y will be equal to this.y plus this.dy essentially. And now I also have to call this method, of course, right before drawing it, for example. So circle.update like this. And now you can see all of them are essentially going down. But we're never clearing the screen, so this here looks a little bit weird. So right in the beginning, we could, for example, use a black overlay to slowly fade the circles out. So let me, for example, say ctx.fill_rect. I want to fill our entire rectangle, so 0, 0, canvas.width, canvas.height. So this will fill our rectangle. But I did not set a color yet, so I'm going to say for ctx.fillRect, I want to use ctx.fillStyle, so a color of RGBA 000, so black, but only a transparency of 0.1, like this. And now you can see we're getting this cool effect where we have this nice line behind it. So I think this looks pretty nice already. Next up, I would also like to add the speed for every single circle. So I want to add gravity essentially. And in order to do so, I have to add speed on every single frame. So we do not only want to change this.y, but we also want to increase the speed of this.dy. So I could say this.dy plus equal 1, for example. So the speed gets faster with every single frame, as you saw. And now let me also decrease the speed scaler a little bit. So let's start at a speed of 2, for example. And you can see this gets a lot faster already. You can also try 10. So I can just test this out. But that's up to you. And we'll test this later on anyways. Now I also want to have a bounce off the bottom essentially. So I need to check whether our circle is outside of the canvas. If that is the case, then I need to invert the movement direction. So this.dy. Because by default, this.dy points to the bottom. But once we hit or once we get outside of the frame, then we need to say this.dy should now point to the top. So this.dy should be equal to minus this.dy. So we check if our position, so this.y, is greater than the canvas height essentially. So canvas.height. And if you want to be precise, you should also subtract the radius from our canvas height. So minus this.r. So if that is the case, then I want to say that this.dy is equal to minus this.dy. And right here I used the wrong brackets. So let me use the right ones. Whoops, again. And I don't know what I'm doing. Like this it should work. And you can see now all of those circles are essentially bouncing off. But the speed is a little bit too fast for me. So let's start with a speed scaler of 1. And we should also say, once this condition becomes true, that we want to reset this.y to the absolute bottom right here. So I'm going to say this.y is going to be equal to canvas.height minus this.r, so minus the radius. And now this should work perfectly fine. I also want to add gravity though, because I want this here to jump a little bit less after every single contact with the ground. So I could say gravity, friction, doesn't matter. So const friction might make more sense. It's going to be equal to 0.9, for example. And now I'm going to multiply this dot dy, so minus this dot dy, by 0.9. So this here gets less or a little bit less every time it hits the ground. And now you can see every time it hits the ground, the jump gets a little bit less. And at some point, it's essentially just lying on the ground. So next up, we should check when it's lying on the ground. And if that is the case, then we want to respawn it at the top, at the old Y position essentially. And in order to keep track of the old Y position, we should save the original position somewhere. So we could say this dot original Y is equal to Y. So the one that we used in the beginning to assign a value to this dot Y. And we never touch original Y, we only use original Y to reset this dot Y. So let me show you. Right in the beginning, I want to check if our dy speed is very, very small, because if it is very, very small, then it means we're not jumping that high anymore. So if this dot dy is less than 2, for example, and this dot dy is greater than minus 2, so essentially if it's between 2 and minus 2, then we're obviously very slow, and we're only very slow if we're either not jumping a lot anymore, so if we're essentially at the bottom and lying there, or if we're at the top and essentially turning. So I also want to check whether we are lying on the ground at the same time and not right here at the top, because there, of course, we could also have a very small velocity or speed overall. So I also need to check and this dot y, so our position, this dot y, plus 10, for example, is greater than our canvas dot height minus this dot r, so minus the radius. So canvas height minus radius essentially means be right here for the radius. So have a line at the center of the circle. And once this dot y plus 10 is below this line, so essentially if it's lying and those other conditions are true as well, then we want to spawn it again at the top. And plus 10 is literally just a random value. I just want to make sure that I'm below the line. So it could also be plus 5, plus 3, but plus 10 is kind of safe and I go with that. But now under those circumstances, I say that this dot y is going to be equal to this dot original y. So I just store this right here. So let me save this and let's test whether this works. And once one of those balls essentially stops to jump, then I want to make sure that the ball respawns at the top. So let's take a look, and you can see that one actually respawned. So now a lot of those balls are just respawning over and over again. Now we could also create less circles so we understand this a little bit better. So maybe let's only use 5. So now we have those 5 circles, they're dropping and fall again. So now there's only essentially one thing missing. We need those particles at the bottom that spawn once the ball essentially hits the ground. And I want to have another class for those particles. I want to have a small circle class, for example. So class small circle or filled circle, because I want to have a filled circle for those circles, for those particle circles. So class filled circle. I want to have a constructor. Every single circle will also have an x value, a y value, a dx value, so speed into the x direction, the y value, so speed into the y direction, and a radius as well. And I'm just going to say that this dot x is equal to x, this dot y is equal to y, this dot dx is equal to dx, this dot dy is equal to dy, this dot r is equal to r, like this. Now I also want to have a draw method, so draw like this, and I also want to have an update method. And we'll actually implement them once we understand how this works, like this. So actually let me draw an example for you. So once our circle hits the bottom, we then want to spawn all of our circles essentially at the point where our big circle is at the moment. So all of our small circles will by default have the x value of our big circle. So filled circle will have the x value and the y value of our normal circle at the moment at which the big circle hits the ground. Radius for our filled circle will be a lot smaller. And for dx, it's important that dx can be negative, so left, and it can also be positive, so right. But for y, it's really important that it can only be negative. So negative y essentially means upwards. So dy always needs to be negative for us if we want our particles to go to the top. And of course, at the bottom, it does not really make sense for our particles to go to the bottom, so downwards. Therefore, dy always needs to be negative. The x needs to be positive and negative to have a cool particle effect. So let's implement that right now. First of all, I also want to have a small circles array. So let small circles be equal to this empty array for now. And every time our big circle hits the ground, so now right here, we want to create the small circles when the circle hits the ground, and we want to add them to our small circles array. So let's do this. Let's say small circles dot push. We want to push into small circles a new filled circle. And now we are calling the constructor as well, and we need to pass x, y, dx, dy, and r. For x, we can just use this dot x. For y, we can use this dot y. But dx and dy needs to be generated dynamically. So let's do so. Let's say const random x, for example, or x speed is going to be equal to math.random. And let me multiply that one with small circle x speed, for example. And now the same for our y speed. So const random y speed is equal to math.random times small circle y speed. But now, as I said, our x speed should be able to be negative and positive because we need some x values to the left and some to the right. So I'm going to say math.random minus 0.5. And now I also need to include those variables, so small circle x speed. So right here, const small circle x speed is going to be equal to 5. Const small circle y speed is also going to be equal to 5. And let me also create a variable const small circle radius or max radius like this. And this is going to be equal to, let me use 3 for now. And let me increase the size of the big circles to 10, for example. It doesn't matter too much. So now I also need small circle max radius, and I create a random radius. So const random radius is equal to math.random times small circle max radius. And I'll pass as a third argument right here random x speed, now random y speed, and random radius like this. So now we are essentially adding all of those circles to small circles, but we're not drawing them yet. So that is what we have to do next. So let's also implement a draw method. Let's say for every single circle, ctx.fill style, and this one is going to be equal to RGBA 0, or let's use 255, 255, 255, so wide, but only a transparency of 0.5. Now I want to use ctx.arc. For x, we'll use this.x. For y, this.y. For radius, this.r. Start angle is going to be 0. End angle 2 times math.pi. And counterclockwise is going to be false, like this. And now, of course, we also need to use fill. So ctx.fill to draw our radius. And I'll also use in the beginning ctx.begin path to begin a new path for every single circle, essentially. So now I'm drawing them, and this here should of course be update, but I'm not updating yet. But let's first of all start on drawing them and see whether this even works. So I'm just going to say within this animate method that I also want to loop over my small circles. So small circles dot for each. I'm getting one circle for every single circle in my array. And now I'm just going to call circle.draw on every single circle. So we should at least see them. And you can see we are essentially seeing them. We are adding those small circles, but they're not doing anything at the moment. So we also need to update them to make them move. So let's update them next. For update, let me just say that this.x is going to be equal to this.x plus equal this.dx and this.y plus equal this.dy. So now they should move once I call the update method. So right here, before drawing, let's say this dot, or circle to be precise, circle.update. So now we're updating them, and now they should actually move. And you can see they're actually moving in the wrong direction at the moment. So that is of course not what we are looking for. So somewhere here should be a mistake for our small circles. So let's take a look. Small circles.push. And actually random y speed always needs to be negative, as I said. So now this should work. Okay, so actually you see we are only creating one single circle at the moment. So we should also use a for loop to create a couple of small circles. So let me just say for let I be equal to 0. We're going to execute this one as long as I is less than amount of small circles and I plus plus. And now let's just do this run right here again. So we're creating a lot of different small circles now. And let me also initialize this variable. So const amount of small circles. And let's say we create 10 small circles every time they hit the ground. And you can see this is now the effect. So this looks a lot better already. But we should also make them despawn after a certain amount of time. So we should give them a lifetime, the small circles. Because right now this looks just like a firework. Maybe you want this, but for my case, I do not want this. So I'm actually going to use a lifetime right here. I say this dot lifetime is equal to lifetime like so. And I'm going to decrement the lifetime every single time we update. So for every single tick. So I'm just going to say this dot lifetime minus equals 1. So I decrement lifetime by 1. And now within our animate method, after we printed all of the radiuses, or right before we printed all of the small radiuses, we could also check whether a circle has a lifetime of 0. And if that is the case, we want to remove it from our array. So essentially delete it. So we can just say small circles dot filter. We're going to get one small circle for every single iteration. And we're going to return our circle only if small circle dot lifetime is greater than 0. So is at least once. Because otherwise the lifetime is 0 and then we just want to delete it from our small circles. So let me try this. And actually at the moment we do not have a lifetime, so we should of course also implement that one. And for all of the circles we could just use a lifetime, whereas small circles, so right here, lifetime of maybe, let's use 10 to just test this. And actually this does not work, and the reason is of course that I'm not storing this within small circles. So small circles is going to be equal to small circles.filter. And you can see now they immediately disappear essentially. And this is exactly what we want. Of course, this is a little bit too early, so we can also fix that. But that is something that we can do right now by just experimenting with the values. So I'm going to say lifetime right here. And now I'm going to create a lifetime variable. So const lifetime is equal to, let's say, 100. And now you can see our lifetime is already a lot bigger. Maybe 40 would be a little bit better, and you can experiment with those values. But you can see at the moment they also immediately disappear. So this here looks also pretty abrupt. But now I also want to dynamically pass our alpha value right here, and I want to decrement the alpha value depending on the lifetime. So I could just create a variable, const alpha, for example, that is going to be equal to this dot lifetime divided by the max lifetime, so our lifetime essentially. And this will give me a value between 0 and 1. And the higher our current lifetime compared to the max lifetime, the higher our alpha value. And now I could just say right here that I want to have backtick characters like so. I want to use RGBA 255, 255, 255. And right here I want to use alpha. So I want to use a JavaScript expression and I'll insert alpha right here. And now you can see they essentially fade out. Of course, I could also say alpha minus 0.5. So I start at 0.5. And this here needs to be inside of the brackets, like so. So alpha minus 0.5, and now we're getting this effect. And you could, of course, also increase the amount of small circles. So maybe 25, but that's up to you. Feel free to experiment with those values. You can also decrement the small circle radius, maybe 2. 1, 10. Like, feel free to use whatever you like right there. And now I could of course adjust this effect according to your needs, but I think this is pretty fine, and I think you understood how this works overall. So really hope you enjoyed this effect, hope you have a great day, and see you guys.